you can do is this. I'm going to ask you to take a look at this and go, I got those two variables. I need an equation that relates those two variables. I'm gonna give myself 30 seconds before I jump in there and let Carolyn answer the question. Is there any equations you know that will exist that must relate those two?
Volume and time?
Volume and time, we don't need time. We're going to put time in. We're going to redfern it to get the time. So the equation that relates the V and the R. Apolito, are you thinking at all?
Dude, I actually do not have any equation. Like, I don't even know.
Right. But I just gave you the biggest hint of all, and you're busy talking to your ear.
No, we were talking about the equation, but. Okay.
Were you? Okay.
What was the? No, what was your hint though?
I said we need V and R.
I got it. So that's right.
All right, Apolito. I need an equation that relates V and R. What is it?
Relates velocity.
V is velocity in this equation?
Hold on.
Come on, take a look at Pecorino. Pecorino, she thinks V is velocity.
No,
what is V again?
No, I know it's volume, okay?
Volume. It was a long time ago.
So, volume and rate.
Volume and rate?
Volume and radius.
Volume and radius. It's an equation that relates volume and radius.
Yeah, it's probably volume equals something, something, something.
I'm with you. What the volume equation of a sphere. Now, here's the good news for you. AP Central no longer believes you know what the equation of a sphere is. They did 20 years ago believe you knew what they were, but now they write it on the equation for you. So V equals what? It's 4/3 pi r cubed.
Oh my god.
4/3 pi r cubed. Now, if that's my volume formula, finish the problem. Everybody finish the problem? Go. Let's do the next step. We're going to redfern it next, right?
Which one's your equation? The second one?
You said this is your equation. We're using it.
What about the top one?
There's no equation up there. I wouldn't use the product rule, no. What? It's still a ways out.
Not next week.
Maybe. Actually, you know what? There's almost no chance we're going to have that test next week. Probably quiz next week.
What's that? So the test will be Thanksgiving week?
That would be a good time to have it.
No.
Nearly perfect time to have it.
See, I don't know how to take a derivative of that.
You know how to take the derivative of a number, r cubed?
Well, should we plug in r?
No. All right, V.
V.
What's the derivative of V?
V, I don't know. You don't know what it is.
It's volume. Go see Pecorino. How do I take the derivative of a letter? Like X or Y or 53? Okay, 1. But that's not a T, is it?
No.
So I'm going to write a dv dt because I took the derivative, like the wrong thing, right?
Okay.
Equals. How do I take the derivative of something x cubed? R cubed. Yes?
3 r squared.
3r squared. No, 3 times all this garbage. R squared. But R isn't T, so what am I going to tack on?
2r.
I'm going to what?
Well, you're supposed to tack on a chain, so.
Right.
I thought it was 2r, so.
But we already took derivative with respect to R. That's already taken care of.
Oh, the inside then?
What's the inside? Okay, this pi is freaking you out. If I have a number like 7x cubed, I don't make that 3 times 7x squared times 2x times 2. We didn't start doing that, did we? And it's just 21x squared, isn't it?
Uh-huh.
So because the pi's in here, you're freaking out because you're like, oh, I got 2. No, you don't.
Because pi's a number.
Yes, but it's a number that's multiplied by the 4/3, right? It's just one number here.
Okay.
Like a 7.
Okay.
Okay, so I throw the 3 out front, R, but the thing is the R is not right. So we have to tack on.
The derivative of the inside?
Yes, and what is the derivative of the inside?
If the inside is 4/3 pi. Yeah.
If this was an X to begin with, Would I tack on a chain at all if I take derivative with respect to x?
No.
No. But if I take derivative with respect to anything else, what do I have to do?
A chain.
To tack on what chain? I'm going to throw a dRdt on here and hope a little bit.
Yeah,
You go, oh yeah, that's right. Right? Because R is not T, I have to tack on a dRdt. Is that okay with everybody in the room? Or is,
Yes.
are we good? Pinto, you good? Okay, now what do? Plug in the things I know. dV/dt is 4.5. This becomes 4 pi. R squared is 2 squared times dRdt, which is what I'm looking for, right? So I get 4.5 over 16 pi equals dRdt. And what's my units for this?
What are we?
We just found the rate at which the radius changes with respect to time, right? What's it measured in?
Feet.
Per
Minute.
minute. I can either decimalize that or turn that into 9 feet over 32 pi per minute.
So look at this. How you just randomly put a dRdt over there.
That's what we've been doing for the whole entire chapter. We take the respect to y. When you're if I've got y squared equals x, I take the respect to x. I write 2y. Then what do I have to tack on there? Because that's not an x.
Y prime.
Dy dx.
Because it's not an x?
Because it's not an x, you're taking the respect to the wrong thing. So you must take a chain. The inside is wrong.
Remember how we were tagging
Take the derivative like you normally would. Then you tack on a dy dx.
Well, I knew we did it, but I didn't know why.
That's why. Because when I go to take derivative of this, it's not an x, right? So I'm totally ignoring the fact the inside's wrong. Just like when we do sine
You can only
theta squared, I do a 2 sine theta, then I take the derivative of the inside, right?
Yeah.
That's what we're doing here. We throw the 2y out in front, and then we tack on a, because that's a y, that's not an x, I'm going to have to tack on a dy with respect to x.
So that one makes sense, but how do you know this is, how do you know t is the equivalent of x in this? Right? Because it's not t, you said.
It's not an r. The t, I take the respect to time, right? Is that time?
So it's always time? How do you know what you're taking it for?
Because we asked the rate at which the thing is getting bigger. I would choose time, right? Because normally that's what you, if I'm talking about how fast a balloon is blowing up, usually that's a time thing.
Is it always time?
Usually. Not always. I can make a relay rate work on anything. It's an incredibly powerful tool because it works on anything.
Yeah, so how do you know what it
Because
is?
you read the question, you go, oh, it's asking me how fast something's blowing up, so I'm going to use time. Does that make sense?
Okay.
You're going to look at it and you're going to go, it's asking me this question. I need to know this. Actually, probably should have written that down. We didn't write down what we need to know. We didn't write that down. We're looking for dRdt. My bad. That should have been written down, right? And what we need to know. Okay, let me pause this. X equals 1. I know that. Love it. What else do I know?
Dx over dt.
The derivative of x with respect to time is equal to what? Is 2 at x equals 1. And anything else I know?
The equation is 1 equals x.
It's not something I know. It's not a number or something like I could put in a thing. I'm going to pause on that. We do need that information, though. If you wrote it down, it wouldn't hurt you at all, even a little bit. What do I want now?
Dy over dt.
Y over t. The derivative of y with respect to time is what I'm interested in finding. Fair enough. Now I'm going to pause here. Next step is to figure out an equation that relates the things in that equation that I know. Back to what are you doing? I just want an equation that relates x and y.
Y equals x.
Y equals, thank you, x squared plus 3. Aha! Now, be aware of this. One of their favorite tricks is this. Hey, ducks at a duck farm, when they squawk at night, can tell you the temperature of the trees in the following equation. Blah, 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 blah. And then they start talking about cows or something. At the very end, they ask you something like, what's the rate at which the ducks are squawking on a day when the trees are at temperatures changing at this rate? What are they doing? They're giving you the equation. This one's obvious, but down the road you're going to run into situations where they're going to like, it's interesting to know the following equation, and then they start asking something that seems completely random. Go back and take a look at that equation, right? Very well could be they're giving you the answer. Or at the very end they say the volume of a sphere is, well then probably that's the equation I'm going to use, right? Does that make sense, everybody?
Yes.
Okay, so watch out for that. Okay, so then I got a Redford it. It's Fleming, how do I Redford in this?
So the y times dy equals 2x.
Okay, so you're writing that answer. I'm going to take the with respect to time. Why time, Carolyn? Because that's what I'm looking for. I want a dt. I'm looking for a dy dt. I need a dt on the bottom, which is going to take the with respect to time. I have no t's in my equation. I need to make it happen. So I'm going to take the with respect to time of both sides. Does that make sense? That's what you're tripping on last time. Does that make sort of sense? I'm looking for dy dt. I better make this a dy dt, right? So I take the derivative of both sides with respect to time, which means this is a 1. But that's not a t, so I have to tack on a dy dt. X squared, that's going to be a 2x. But that's not a t, so I have to tack on a dx dt. What's the derivative of 3? 0 goes away. Now I'm going to plug in what I know. Whoops, 2 times 1 times 2. What do I get? 4. What's my units? It's a stinking math class. They didn't even give you any. Right? So learn to deal with that. Stop putting down units when you don't have them. The other class is firmly convinced that this is meters per second. No, it's not. And don't put it down because they'll actually mark you wrong. They're like, well, that's not meters in seconds. You're wrong. So don't write it down if it's not true, right? It's a math class. Sometimes we don't have the units. Okay? Everybody try a pebble dropped in a pond. This is like the best one. This is like